For as long as humans have lifted their eyes to the night sky, a single question has followed us across time. Is this all there is, or are we just one world among many? Long before telescopes and equations, ancient cultures sensed that reality might be layered and vast. Myths spoke of hidden dimensions, parallel heavens, and realms existing just beyond perception. In Hindu philosophy, the universe was never a one-time event. Instead, it was caught in an endless rhythm, universes forming, dissolving, and being reborn across unimaginable spans of time. Greek thinkers like Democritus went even further, daring to imagine infinite worlds scattered through the void, some familiar, others utterly alien. For centuries, such ideas lived in the realm of philosophy and myth. Yet today, those ancient intuitions feel strangely prophetic. Modern science has begun to echo what storytellers once whispered. With every new discovery, the universe has proven to be far larger, stranger, and less centered on us than we ever imagined. For most of human history, people believed Earth stood at the center of everything. Aristotle's orderly, Earth-centered cosmos offered comfort and clarity, placing humanity at the heart of creation. That vision endured for nearly 2,000 years, until Copernicus shattered it. The Earth, he showed, was not the center. It was merely one planet circling the Sun. Even that revelation was only the beginning. Later astronomers discovered that the Sun itself was nothing special, just one ordinary star among hundreds of billions in the Milky Way. Then, in the early 20th century, Edwin Hubble delivered another shock. Our galaxy, once thought to be the entire universe, turned out to be only one among countless others. The night sky was not a ceiling, it was a doorway. Every faint smudge of light was a galaxy of its own, each holding billions of stars and potentially countless worlds. With each breakthrough, the boundaries of reality moved farther away. As telescopes improved, scientists noticed something even more profound. The universe was not standing still. Distant galaxies were rushing away from us, carried by the expansion of space itself. When scientists traced that motion backward, they arrived at a staggering conclusion: the universe had a beginning. Everything, space, time, matter, and energy, emerged from an unimaginably hot and dense state we now call the Big Bang. Even today, a faint echo of that birth remains. The cosmic microwave background, a soft glow spread evenly across the sky, is the cooled afterglow of the universe's earliest light, a silent reminder that everything we see came from a single, ancient moment. But the early universe presented a puzzle. No matter where astronomers looked, the cosmos appeared almost perfectly uniform. Regions separated by billions of light years, too far apart to have ever exchanged information, looked nearly identical in temperature and structure. It was as if the universe had been carefully coordinated from the start. To explain this mystery, physicists proposed a bold idea: cosmic inflation. According to this theory, the universe experienced a brief but violent growth spurt in its first instant, expanding exponentially faster than light. During this fleeting moment, tiny quantum fluctuations were stretched across vast distances, becoming the seeds of galaxies, stars, and planets. Inflation didn't just solve technical problems in cosmology. It quietly transformed our understanding of reality. If inflation is correct, space may be flat and endless. And if space is truly infinite, then what we can observe, the visible universe, is only a tiny fragment of something vastly larger. In an infinite cosmos, the number of possible ways matter can arrange itself is limited. Given enough space, those arrangements must repeat. That realization leads to a deeply unsettling idea. Somewhere far beyond the reach of our telescopes, there could be regions of space nearly identical to our own. Worlds like Earth. Skies like ours. People living lives strikingly similar to yours. In one region, events unfold almost exactly the same. In another, a single choice diverges. A word spoken differently. A decision delayed. A life quietly altered. This framework was formalized by physicist Max Tegmark, who described different levels of the multiverse. The first level, the simplest yet most disturbing, suggests that beyond our cosmic horizon, space continues forever. The laws of physics remain the same, but the initial conditions differ slightly from place to place. In that endless expanse, probability becomes destiny. Every outcome allowed by physics doesn't just might happen, it must happen. And not just once, but endlessly. Somewhere, there may be another version of you reading these very words. Somewhere else, a version who made one small different choice. And somewhere unimaginably distant, a universe identical to this one in every detail, down to this exact moment. The question, then, is no longer whether we are alone in the universe. It is whether this universe is only a single chapter in a story far larger than we can comprehend, and whether reality itself is more vast, repetitive, and mysterious than we ever dared to imagine. But as radical as the level 1 multiverse sounds, it is only the beginning. Because this idea rests on a quiet assumption, that the laws of physics are the same everywhere. Gravity behaves the same. Electrons have the same charge. Time flows forward in the same way, no matter how far you travel. Level 1 universes differ only in arrangement, not in rules. Yet physicists began to ask a deeper question. Why do these laws exist at all? Why does gravity have exactly the strength it does? Why do particles have the masses they have? Why does the universe allow stars, chemistry, planets, and life instead of collapsing instantly or flying apart into nothingness? The equations of physics contain dozens of numbers that seem finely tuned, balanced on a razor's edge. Change them slightly, and the universe becomes lifeless. For a long time, scientists hoped these values were inevitable, that one final theory would explain why the universe could only be this way. But decades passed, and no such necessity emerged. Instead, modern physics pointed in an unexpected direction. What if the laws themselves can vary? This possibility arises naturally from inflation. In some versions of the theory, inflation doesn't stop everywhere at once. While our region of space cooled and settled into a familiar universe, other regions continued inflating, ballooning outward and spawning new cosmic bubbles. Each bubble becomes its own universe, cut off from the others, with its own physical properties. This is known as eternal inflation. In this picture, reality is not a single expanding universe, but a vast cosmic foam. Bubble after bubble forms endlessly, each one a separate universe with its own constants, its own particles, even its own dimensions. Some universes may collapse instantly. Others may never form stars. A rare few, like ours, happen to land in the narrow range where complexity can grow. This is level 2 of the multiverse. Here, the differences are no longer small. These universes are not copies with shuffled atoms. They are fundamentally different realities. Chemistry might be impossible. Time might behave strangely. Entire categories of matter could be absent. Most would be utterly hostile to life.